Hello, this video presentation is on graphing radical functions. Graphing radical functions is really very simple. Just like quadratic functions, we find that all of our graphs look almost exactly alike. They're just starting at a different spot. We don't call it a vertex, but essentially it's the same thing. To start, we want to find a starting point. Find the starting point. To do that, we set x equal to, not x, but the radicand. Set radicand equal to 0. The radicand is this highlighted part here. This is the radicand, x minus 3. What's inside the radical? So, x minus 3 equals 0, x is equal to 3. So our starting point is the ordered pair 3, 2. Where did this 2 come from? Well, when x is 3, 3 minus 3 is 0. Square root of 0 is 0. 0 plus 2 is what y is. Y must be 2. It's always going to be this number. That's always going to be the y-coordinate of our starting point. Let's look at that once more. Y equals 2 plus the square root of 3 minus 3. 2 plus the square root of 0. 2 plus 0. Or y is equal to 2. So our starting point here is 2, 3. All right, so let's make a little table of values here. Y equals 2 plus square root of x minus 3, x, y. Our starting point is 2 and 3. If I put in a number smaller than 3, I get a negative in the radical. Those are not real numbers, so we're not going to use them. All right, we're going to use numbers bigger than 2. I did that backwards. I am so sorry. So x, did I? 3, 2. X is 3, y is 2. We're going to use numbers bigger than 3. Smaller than 3 gives us a negative number. So I'm going to put in 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now, 4 minus 3 is 1. So 4, it's 2 plus square root of 4 minus 3 is 2 plus square root of 1. 2 plus 1, we get 3. If I put in 5, 5 minus 3 is 2. I don't know the square root of 2. If I put in 6, 6 minus 3 is 3. I don't know the square root of 3. If I put in 7, 7 minus 3 is 4. All right? So I'm going to erase this. I'm going to move the 7 up here. And we have 2 plus the square root of 7 minus 3, 2 plus the square root of 4, or 2 plus 2, which is 4. Now, 8 minus 3 is 5. Square root of 5, I don't know it. 9 minus 3 is 6. Square root of 6, don't know it. 10 minus 3 is 7. Square root of 7, don't know it. 11. 11 minus 3 is 8. Square root of 8, don't know it. 12 minus 3 is 9. Well, I know the square root of 9. So 2 plus the square root of 12 minus 3, 2 plus the square root of 9, and 2 plus 3. So I'm at 5. Now, this seems like a lot of work to do one graph, but it's work you will never ever do. Notice that 4 is 1 bigger than 3. 7 is 4 bigger than 3. 12 is 9 bigger than 3. So this is 1 bigger, this is 4 bigger, this is 9 bigger. Do we notice something from graphing quadratic equations once we found the vertex? It's extremely similar. The next number would be 16 larger. If we went to 19, which is 16 larger than 3, 19, let's see, 2 plus square root of 19 minus 3, 2 plus the square root of 16, or 2 plus 4 is 6. Our parabolas are always going to have this basic shape. There's never going to be an exception. All right, so let's draw our parabola. Okay, ordered pair. Oops, I got to move my graph. All right, now we can begin to graph. So, first ordered pair is 3, 2. 1, 2, 3, 2. Next ordered pair, 4, 3. Then 5, 6, 7, 4. 8, 9, 10, 11, 12, 5, and 13, 14, 15, 16, 17, 18, 19, 6. All right? And we then attempt to very smoothly, do it in a different color, very smoothly join this. This shape is just like our parabola, except it's oriented in a different direction and only half of the parabola. And notice we went from this starting point over 1 up 1, over 4 up 2, over 9 up 3, and over 16 up 4 from the starting point. All right, let's do one more without all this work. Okay, our starting point is going to be x equals -5, because -5 plus 5 is 0, -4. So -5, 1, 2, 3, 4, 5, 1, 2, 3, 4. Then we're going to go over 1 up 1, over 2, 3, 4 up 2, 4, 5, 6, 7, 8, 9 up 3, 10, 11, 12, 13, 14, 15, 16 up 4, and our graph paper will never be big enough to go 25. And then we draw our smooth graph, hitting all the points, drawing an arrow. I think I forgot the arrow on the last one. No, I didn't. And we're done. All these parabolas are going to have the same basic shape, just a different starting point. All right, hope that makes sense, and have a great day. See you tomorrow.